Good evening.
Good
Yeah, good evenings. Hello, ma'am.
Yes, sir.
Yeah, ma'am. I'll start, ma'am. The last class we were learning with the preparation of aldehydes and ketones, or the preparation of aldehydes and ketones. We learned various methods of preparation of aldehydes and ketones. Right, few more reactions we need to learn. We will learn those reactions and then we'll continue. These all are so many more methods are there. I taught you Rosenmann's reaction, Stephen's reaction, that is from nitrile. All this we have learned. Few more reactions and then we'll continue with the question and the topics. Now, distillation of calcium, barium, strontium, or thorium salts of monobasic acids. Now, calcium salts of carboxylic acids, when you dry distillation is heating in the absence of air and moisture, is called as dry distillation. So calcium salt, now for an example, if you take for calcium formate is formic acid is HCOOH. And if it is allowed to react with calcium hydroxide, what happens? This calcium will displace these two hydrogen atoms. So you get calcium formate HCOOCA. This is calcium formate. Now, this calcium formate, when you dry distill, HC double bond OH. This is for a competitive exam. It is not there in the syllabus. This calcium formate, when we dry distill, when you heat it in the absence of air and moisture, always the byproduct will be calcium carbonate. The byproduct will be calcium carbonate, CaCO3, calcium carbonate. Once byproduct calcium carbonate is eliminated, what else is left out? We have HCHO. So this is called as formaldehyde. This is called as formaldehyde. Now, similarly, this is with respect to what? Formaldehyde preparation from calcium formate. So calcium formate on dry distillation gives formaldehyde. Now we'll see calcium acetate, we will see. When we take calcium acetate, what will happen? You observe. Calcium acetate is this, acetic acid and calcium hydroxide. So the molecular formula is this. This is calcium acetate. When calcium acetate is dry distilled, again, the byproduct is calcium carbonate. When byproduct calcium carbonate gets eliminated, what we have? We have CH3, C double bond O, and you have CH3. Now the product formed is acetone. Acetone is a ketone. Acetone, CH3, CO, CH3. This is a ketone. Now we will take one more example and let's see. If you take calcium benzoate, now calcium benzoate is benzoic acid. Calcium benzoate, and we will take calcium acetate. Both calcium formate we will take first. Calcium benzoate and calcium formate. So mixture of two salts we are going to take. One is calcium benzoate, C6H5CO. The other one, C6H5CO. This is called as calcium benzoate. Now this is dry distilled along with calcium formate. This is calcium formate. Calcium formate. When you heat it, in both the cases, calcium carbonate will be a byproduct. So calcium carbonate. So how many calcium carbonate is getting eliminated? 2 moles. From 1 mole from here, 1 mole from here. Now, in order to understand the product, when we take different types of calcium salts, so this, which is on the upper part of this molecule, calcium benzoate, this is calcium formate. So we'll react with the lower part of calcium formate. So what will happen? You get the C6H5 CHO. So you get benzaldehyde. The product what we get is benzaldehyde. Now, similarly, this will react with this opposite. So C6H5 CHO. So again, benzaldehyde. How many moles you'll get benzaldehyde? So calcium benzoate and calcium formate gives benzaldehyde. Benzaldehyde. Are you following?
Yes, sir.
Yeah. Now, similarly, instead of calcium formate, if we take calcium acetate, what will be the product you will get? Now, before we could understand the product, we should understand here it is calcium acetate. It is CH3 here. So what happens? Again, calcium carbonate, 2 moles gets eliminated. Oppositely, try to bond. So C6H5, C double bond O, and you have CH3. So this is called as acetophenone. Acetophenone. How many moles of acetophenone? C6H5, COCH3. 2 moles of acetophenone. So you should remember, when a mixture of calcium benzoate and calcium acetate is dry distilled, acetophenone. So therefore, the answer for this question, not the question, for the reaction is acetophenone. All right. The next one is, this is the what they've given. They've given cyclopropanone here. Now, calcium, this is cyclopropanone. The C double bond O here, ketone, cycloketones also can be formed by the dry distillation. This is dicarboxylic acid, calcium salt of a dicarboxylic acid. See, 2 carboxylic acid group. Now, for an example, it is CH. No, I'll take another color. Yeah. Now, if we take this molecule, COOH, CH2, CH2, COH. It is a dicarboxylic acid, 2 carboxylic acid group. If this is allowed to react with calcium hydroxide, this 2 OH and these 2 hydrogen gets eliminated as 2 water molecule. So what you have now, we have CH2, I'll write here, you have CH2, you have another CH2 here, and this is COOH, COO, H is reacted, COO. And here also we have COO, and since we have calcium, it is Ca. This is a calcium salt of dicarboxylic acid. So this, when you dry distill, again the byproduct gets eliminated. The byproduct is calcium carbonate. Now, when the byproduct gets calcium carbonate, this oxygen also, this of CaCO3, calcium carbonate. So what we have now, we have CH2, you have C double, this is C double bond. This is called a cyclopropanone. So cycloketones and aldehydes also can be prepared by the dry distillation of calcium salts. As I told you in the beginning, this is for competitive exam, purely for competitive exam, because in 12th standard, we do not have the dry distillation of calcium salts of carboxylic acid. The next reaction is decarboxylation or dehydration. Decarboxylation or dehydration. So this reaction takes place between two molecules of carboxylic acid. Both may be same or different. Both may be same or different. Decarboxylation means removal of carbon dioxide. Dehydration of acid. Dehydration means removal of acid. Now, this reaction takes place between two molecules of carboxylic acid. Both may be same or different. If one carboxylic acid is HCOH, then this acid undergoes decarboxylation because this acid is the only monobasic acid which undergoes decarboxylation even in the absence of catalyst. So formic acid will undergo decarboxylation even in the absence of catalyst. So when both the molecules of formic acid, HCOOH is formic acid. So the other molecule HCOH is this. Both are formic acid. Now, in the presence of manganese oxide as a catalyst at 300 degrees Celsius. So what happens here? Carbon dioxide gets eliminated. Carbon dioxide gas gets eliminated as one of the byproduct. Now, this OH and this H gets eliminated as water. The second byproduct is water. What is left out? We have H, C double bond O, and you have H. So this is called as formaldehyde. This is called as formaldehyde. So when both carboxylic acid are heated, decarboxylation and dehydration both takes place. See here, carbon dioxide is eliminated, decarboxylation. Water is eliminated, dehydration. So to form formaldehyde. If we have other, for an example, if I have an acetic acid here, CH3, C double bond O, OH, acetic acid, and if we have formic acid. So again, in the presence of manganese oxide at 300 degrees Celsius, what happens? Carbon dioxide of formic acid only gets eliminated because it's easily decomposable, even in the absence of catalyst, carbon dioxide. And here, this OH and this H gets eliminated as water. So what else is left out? You have CH3, C, double bond O, and you have H. So the product we get is acetaldehyde. Acetaldehyde. So carboxylic acids, organic molecule, dicarboxylic acid, it can undergo dehydration as well as water, decarboxylation to form aldehydes and ketones. The next set of reaction is from geminal dihalide. What do you mean by geminal dihalide? Halogens, if they are present on the same carbon atom, then it is called as geminal dihalides. Now, for an example, if I take a molecule like the CH3, CH, Br, and Br, this is geminal dihalide because on the carbon atom, we have two hydrogen atoms. So whenever the halogens, two halogens, dihalogens, or two halogens are present on the same carbon atom, it is called as geminal dihalide. When this is hydrolyzed, in the presence of a base, what happens? Now this bromine and this hydrogen, two hydrogen gets eliminated as 2HBr. When they get eliminated as 2HBr, what else we have? We have CH3. Hydrolysis is addition of water. Reaction with water is called as hydrolysis. So you have CH3, you have CH, and you have oxygen. This is called as acetaldehyde. It is called as what? Acetaldehyde. So we can prepare a carbonyl compound even by hydrolysis of geminal dihalide. The next one is by ozonolysis. This you have been learning it from first PUC, ozonolysis. Ozonolysis is reaction with ozone. Now, for an example, we will take an alkene, that is propene we will take. CH3, CH double bond, CH3. It is CH3, CH2 double. This is propene. This is called as reductive ozonolysis. Now, this propene, this is an important question. For competitive exam, you have this question, ozonolysis. This, when we treat it with ozone, first is ozonolysis, next is hydrolysis. So what happens is this oxygen, this ozone gets bonded between two carbon atoms in this fashion, CH3, CH, we will write it like this. This is oxygen, this is CH, another oxygen like this. So both the bond between carbon and carbon, double bond gets what? Broken. So it forms like a bridge. This is called as ozonide, and you have a CH2 here. This double bond, both the bonds break. One of the oxygen attacks two carbon atom. The second oxygen attacks this carbon. The third oxygen attacks this carbon, and these two carbon atoms are bonded. Now, when you hydrolyze this, what happens is, in the presence of an acid, this splits like this. So what you get? CH3, CHO. The first product is acetaldehyde, CH3, CHO, plus HCHO. Two hydrogen atoms are there. That's why I'm reading it like this, HCHO. The next one is formaldehyde. So two aldehydes are formed. This process is called as ozonolysis. So alkenes on reductive ozonolysis gives you carbonyl compounds. This is an important question, ozonolysis. Oxo process, Vacuous process, we do not have in our syllabus. So we are not going to learn. Hydration, this also, it's, maybe we will learn this. This is one of the questions we'll ask. Hydration with dilute sulfuric acid and 1% mercury sulfate. This is there for a competitive exam. Hydration of alkynes. Alkynes are molecules containing a triple bond. Now this molecule, now the same example is given here. We will write the same thing and try to understand. Now we can have H and OH. Water, we can write H and OH. The hydrogen, this hydrogen atom attacks this carbon and this OH attacks this carbon. Therefore, what happens? One pi bond breaks. If one pi bond breaks, you have CH2 double bond CHOH. CH2 double bond CHOH. This is an intermediate compound. The molecule is not stable. Therefore, they undergo rearrangement. So what's that rearrangement it undergoes? The rearrangement it undergoes is this hydrogen attacks this carbon. When this hydrogen attacks this carbon, the double bond gets shifted between carbon and oxygen. Therefore, what we get? You get CH3, you have CH, this CH, and since this double bond shifts between carbon and oxygen, we get a double bond between carbon and oxygen. Therefore, the product what we get is called as acetaldehyde. Did you understand this reaction? Hydration. Understood?
Yes, sir.
Rosenmann's reaction we learned in the last class. Nitrile-Stephen reaction we learned it in the last class. Neff's reaction is complex, but it's not there in the syllabus, so we will not talk about it. The other reactions we have, from Grignard reagent, we can prepare aldehydes and ketones. From esters, we have, all right, Gattermann's reaction, sorry. Can you see the screen, students?
Yes, sir.
Yeah. So we will learn this Gattermann's reaction, and then we'll come back to the other set of reactions. Gattermann's reaction, Gattermann's-Koch reaction, we will learn. Now, these are named reactions which are important for your regular first standard exam. So otherwise also you should remember named reactions are always important. Gattermann's reaction. Now what is this Gattermann's reaction? When benzene, hydrogen cyanide and hydrogen chloride are heated in the presence of anhydrous zinc chloride or anhydrous aluminum chloride, an imine is formed. Which on hydrolysis gives benzaldehyde. So Gattermann's reaction is this. When benzene, hydrogen cyanide and hydrogen chloride are heated in presence in presence of anhydrous zinc chloride, anhydrous zinc chloride or aluminum chloride, and imine is formed. This imine means NH group. Imine is formed because cyanide contains nitrogen also. So imine is formed. This on hydrolysis, benzaldehyde is obtained. This on hydrolysis, benzaldehyde is obtained. So we are not learning the mechanism. So therefore, we will simplify this reaction. So this is benzene. When benzene is allowed to react with hydrogen cyanide in the presence of anhydrous zinc chloride and HCl, anhydrous zinc chloride and HCl, followed by hydrolysis. This is the first reaction. This will give you imine. Followed by hydrolysis gives you benzaldehyde. The product is benzaldehyde. This is important, and this is called as Gattermann's Koch reaction. No, Gattermann's reaction, not Koch. Gattermann's reaction. G-A-T-T-E-R-M-A-N. Gattermann's reaction. Did you understand? Followed?
Yes, sir.
Yeah. Next is Gattermann's Koch reaction. What is this Gattermann's Koch reaction? Similar reaction only, but it's a reaction between benzene, carbon monoxide, and HCl in the presence of anhydrous aluminum chloride or cuprous chloride. So reaction of benzene, carbon monoxide, and HCl are heated in the presence of anhydrous aluminum chloride. Benzaldehyde is obtained. So Gattermann reaction and Gattermann-Koch reaction is all the same, but the reagents are different. Now, in case of benzaldehyde, Gattermann-Koch reaction, benzene, carbon monoxide, and HCl in the presence of anhydrous aluminum chloride, the reaction what we get is benzaldehyde. Since we are not learning the mechanism of this reaction has to be memorized or remembered from your memory, because it's not easy for us to explain the mechanism, the complex mechanism here. That is why for Gattermann's reaction and Gattermann-Koch reaction, the mechanism is not given in your syllabus. Both these reactions together are called as formylation. Formylation. See, Gattermann's reaction, in a chemical reaction in which aromatic compounds are formylated by a mixture of hydrogen cyanide and hydrogen chloride in the presence of a Lewis acid like anhydrous aluminum chloride or zinc chloride, is called as Gattermann's reaction or Gattermann-Koch reaction. The next reactions we'll have to learn is from Grignard reagent, acid chlorides, all that. Riemann-Tiemann reaction we learned in phenol, so there's no point in explaining Riemann-Tiemann reactions. And repetition, phenol plus chloroform and sodium hydroxide gives you salicyl aldehyde. Salicyl aldehyde. This is called as Riemann-Tiemann reaction. So you can prepare aromatic aldehyde like salicyl aldehyde by also called as Riemann-Tiemann reaction. The next set of reaction in terms of preparation, what we have to learn is from Grignard reagent. Using Grignard reagent, we can prepare an aldehyde or a ketone. Now, Grignard reagent, everybody knows that it is RMGX. Grignard reagent. From Grignard reagent. The general formula of Grignard reagent is RMGX. So alkyl magnesium halide or aryl magnesium halide. That's how we've named the Grignard reagent. Grignard reagent on nitriles followed by hydrolysis gives ketone. So the statement is Grignard reagent on nitriles. Nitriles are nothing but cyanides. Grignard reagent on nitriles, followed by hydrolysis gives ketones. So it is very specific. It does not give aldehydes, it gives only ketones. So Grignard reagent on nitriles followed by hydrolysis gives ketones. Now, if we take an example, CH3C triple bond N, it's a cyanide. Cyanide is also called as nitriles. This will be called as ethane nitrile. Since we have two carbon atoms, eth, carbon to carbon single bond ethane, and cyanide we have, therefore it's called as nitrile, ethane nitrile. This ethane nitrile, carbon to nitrogen, we have a triple bond. This ethane nitrile, when we heat it with or react it with a Grignard reagent, example, methyl magnesium iodide. Methyl magnesium iodide in ether medium. So solvent should be ether. Dry ether, it should not even have water content. Dry ether. So what happens is magnesium is positive and carbon is negative. Why? Because magnesium is a metal. Metals are electropositive. They donate electrons. So since the magnesium donates electron, magnesium gains positive charge, carbon gains electron, therefore carbon gains negative charge. And we also should know that now nitrogen is more electronegative. When nitrogen is more electronegative, nitrogen will have partial negative character and this carbon will have partial positive character. So what happens? Magnesium will attack nitrogen and the CH3 group will attack carbon. So what's that we get? You get CH3, C, single bond CH3, you will get a double bond nitrogen, and we get MgI. So what happened? Since we had a triple bond here, these are added on, one pi bond will break. So now the bond formed between carbon and nitrogen is a double bond. Now this when we hydrolyze, hydrolysis is addition of water. When we hydrolyze this, water we can write 2 moles of water will take. This 2 moles of water we can write it as H and OH, one molecule. The second molecule, I can write it as H2 and O. So what happens, you see, now this gets eliminated as a byproduct. You get MgOHI, magnesium hydroxyiodide. And this also gets eliminated as ammonia, NH3. So the next product which gets eliminated is ammonia. What else is left out? We have CH3, we have C and O. Here C double bond O, and you have what? CH3. This is nothing but acetone. Acetone is an example for ketone. So from Grignard reagent, we can prepare ketones. So this is a two-step reaction. It's a complex reaction. You should understand alkane nitriles or nitriles when treated with Grignard reagent, we get an intermediate compound. This compound on hydrolysis gives acetone. The next reaction which we have to learn is from acid chlorides. Acid chlorides, not with Grignard reagent, we will take the other reaction. From benzene also we can prepare aldehyde and ketone. So we will learn that from benzene. From benzene. The last method of preparation possibly, and then we will go to some of the physical properties or chemical properties of these molecules. So many reactions we have learned, the preparation part of it. Now we'll try to learn the chemical properties. A lot of reactions are there in chemical properties. So if you can remember from last class onwards, we are learning in this chapter aldehydes and ketones, so many reactions. Now from benzene, the last method of preparing an aldehyde or a ketone from benzene. Now, when aromatic hydrocarbons like benzene are heated with acid chlorides or acyl chlorides, acid chloride, acyl chloride, in the presence of anhydrous aluminum chloride gives you aromatic ketone. Now, we will write a statement when aromatic hydrocarbon, when aromatic hydrocarbon are heated, when aromatic hydrocarbon are heated with acyl chloride, acid chloride or acyl chloride, or acid chloride or acyl chloride, in the presence of anhydrous aluminum chloride. The presence of anhydrous aluminum chloride gives aromatic ketones. Now the representation, this is benzene. When then this benzene is allowed to react with acyl chloride, for an example, acetyl chloride, CH3COCl. CH3COCl. This is acetyl chloride. So what happens in the presence of anhydrous aluminum chloride? So what happens? This H and Cl gets eliminated as HCl. In place of this H, CO goes. So we get a benzene ring, C double bond O and CH3. This is a ketone commonly called as acetophenone. Did you follow this?
Yes, sir.
Yeah, very good, very good. The next sort of reactions we will learn chemical properties. Hoping so we have some questions we will learn based on the preparation, and then we will learn the chemical properties. Now the first question is, which of the following compounds with the molecular formula C5H10 yields acetone on ozone analysis? If you are aware of, for the 12th standard exam, the question paper pattern is changed. So first 20 questions will be almost like MCQs and fill in the blanks. So MCQs will be of a lot of use, what we've been doing. So learn. Which of the following compounds with molecular formula C5H10 yields acetone on ozone analysis? Now, an example, we will take an example. 2-methyl-butene. This is the first option we will see. Butene is this 2-butene, CH3, CH, double bond, CH. This is 2-butene. Since we have 2-methyl, what happens is the second position, an hydrogen atom is replaced by CH3. So this is 2-methyl, 2-butene. The first step is, this is treated with ozonolysis, followed by hydrolysis. So whenever we when we react with ozone, the carbon-carbon double bond will break completely. So when carbon-carbon double bond breaks completely, we get CH3, C. This hydrogen CH3 will be here. You have oxygen, and you have carbon, and now this is 3 bond. The other 2 oxygen gets bonded like this, and you have a CH3 group here. This when you hydrolyze in the presence of an acid. So what happens is, now the product what we get is, if you observe this molecule, this part of the molecule. So this is CH3, CO, and CH3. This is called as acetone. So acetone is obtained by ozonolysis of 2-methyl-butene. 2-methyl-butene on ozonolysis, second followed by hydrolysis in the presence of an acid, we get acetone. I hope you followed with this. The next question, among acetic acid, phenol, and N-hexanol, normal hexanol, which one of the following compound will react with sodium bicarbonate solution to give sodium salt and carbon dioxide? Among acetic acid, phenol, and normal hexanol, which one of the following compound will react with sodium bicarbonate solution to give sodium salt and carbon dioxide? We should remember phenol and normal hexanol. phenol and normal hexanol, they are very weak acids. Since they are very weak acid, it will not react with sodium bicarbonate. It is actually weaker than carbonic acid. These two are weaker than carbonic acid. So they will not displace or they will not react with sodium bicarbonate. When acetic acid is allowed to react with sodium bicarbonate, what happens is this acetic acid, the sodium will displace hydrogen. When sodium displaces hydrogen, you get sodium salt of carboxylic acid plus. Now, two hydrogen atoms there. One hydrogen from here gets eliminated as water. So CO3, from CO3, one hydrogen reacts with two hydrogen, one oxygen reacts with two hydrogen to form water, and the left out is a carbon dioxide gas. This carbon dioxide gas, which gets liberated, it will be in the form of effervescence. Bubbles, it get eliminated in the form of effervescence. Therefore, the answer for this question is acetic acid, option 1. The next question, the reagents used for separation of acetaldehyde from acetophenone. So this is an important question for 1 mark. Remember, we have not dealt with this topic. We have to learn the chemical properties, then you will understand. But anyway, the question is here. The reagent used to separate acetaldehyde and acetophenone. Now, acetaldehyde is this. Acetophenone is C6H5, C6H5, C double bond O, CH3. So acetaldehyde, when we allow it to react with sodium bisulfite, it gives a product. So SO3H, SO3 and Na. So you'll get a product like this, CH3, C single bond O, SO3, Na, and this hydrogen attacks this carbon. Because the pi bond shifts here, oxygen gains negative charge and carbon gains positive charge. Therefore, we get hydrogen and hydrogen reacts to form a salt. But here, acetophenone will not react with sodium bisulfite. No reaction. Why no reaction? The no reaction is because of steric hindrance. Because of steric hindrance. So these are all bulky groups. These bulky groups will prevent the attack of this molecule with oxygen. Therefore, this reaction will not take place. Hence, we can separate acetaldehyde from acetone by reacting it with the sodium bisulfite. Bisulfite, NaHSO3. The answer is option 1. Iodoform test is not given by. Iodoform test is not given by. Now, molecules which contains methyl carbinol group. This is called as methyl carbinol. So molecules which contains methyl carbinol group will show iodoform test positive. Iodoform test positive. Now, if we take a molecule like this, now 2-pentanone if we take, or 3-pentanone we will take, CH3, CH2, C double bond O, CH2, and CH3. Now, if you take 2-pentanone, CH3, C double bond O, CH2, CH2, and CH3. Now, in case of 2-pentanone, you can see this contains methyl carbinol. When this is allowed to react with iodine in the presence of a base, NaOH, you get iodoform. It's a yellow precipitate. But here, there is no methyl carbinol. Methyl carbinol group. Since there is no methyl carbinol group, it will not react with iodine and sodium hydroxide. No iodoform will be formed. So iodoform reaction will not be given by 3-pentanone. All the other also will give you iodoform reactions. So 3-pentanone will not give you iodoform reaction. The next molecule, the next question, the products formed when CH3, C triple bond C, single bond CH2, CH3 on ozonolysis. We've been learning this. Now, in case of this reaction, so what happens is Now CH3, C triple bond, C, CH2, CH3. So what happens is when this is treated with ozone, two molecules of ozone will require. 2 molecules of ozone. So I will write directly here 2 molecules of ozone. So what happens is you get CH3, C, O, 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 and what? C. Another ozone molecule gets bonded like this. Another ozone, giving you CH2 and CH3. This on hydrolysis. This on hydrolysis. So we can write water as H and OH. So what happens here is this group, H will react. So what's that we get? We get CH3, CH2, COO, and H. So we get carboxylic acid. Plus, the OH group will attack this. The OH group will attack this group. So when OH group attacks this group, we have CH3, this not OH, the hydrogen attacks. So you have CH3, COOH. So we get CH3, COH, acetic acid. So hence the answer for this question is option acetic acid and propanoic acid. So the answer for this question is option 3, acetic acid and propanoic acid. This is a complex reaction, ozonolysis. The next question. When alkene on ozonolysis gives, which alkene on ozonolysis gives propanaldehyde and ketone? Which alkene? So the answer for this, we will try. We will take this molecule and see. We have CH3, CH2, CH2, CH, double bond C. We will write it as CH3 and CH3. This on ozonolysis. This on ozonolysis. So what happens? Assuming a pi bond breaks, so the compound what we get is we get CH3, CH2, CH, oxygen, 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 and you have a single bond. By one pi bond breaks, C, you have CH3 and CH3. This will undergo decomposition. This will undergo decomposition to form 2 products. One is this. What is this? So you get CH3, CH2, CHO, propanaldehyde. The other one is this. Plus, you get CH3, CO, and you get CH3. This is acetone. This is acetone. Hence, the answer for this question is option 1. So the first option, when we ozonolysis followed by ozonolysis followed by hydrolysis, 2 reactions. This is ozonolysis and this is hydrolysis. It gives you propanaldehyde and acetone. Next question. Benzoic acid gives benzene on heating with X, and phenol gives benzene on heating with Y. Therefore, X and Y is. Benzoic acid is C6H5COOH. When this benzoic acid is heated with soda lime is a mixture of sodium hydroxide and calcium oxide. So soda lime is mixture of sodium hydroxide and calcium oxide. That's called a soda lime. So what happens? So in case of benzoic acid and sodium hydroxide, what happens is 2 moles Na2CO3. Okay, we will get what? A salt. This carbon dioxide gas will get removed. When this carbon dioxide gas gets removed, we're not in a position to show balancing the part. So this carbon dioxide gets removed. So this hydrogen gets bonded to carbon. So you get benzene. So benzoic acid on decarboxylation, this reaction is called as decarboxylation. Decarboxylation is brought about by soda lime. Name the reagent which brings about decarboxylation. The reagent which brings about decarboxylation is called as soda lime. So this is soda lime. The next one is benzoic. Benzoic acid gives benzene on heating with X, and phenol gives on benzene. This is phenol. This phenol, when you heat it with the zinc dust, the zinc and oxygen gets eliminated as O. And what's that we get? You get benzene. You get benzene. So the answer for this question is soda lime and zinc dust. The next question, which of the following on oxidation gives a ketone? So we have learned from the preparation part of it, which of the following gives primary alcohol on oxidation gives aldehydes. Remember, secondary alcohols on oxidation gives ketones. Now, for an example, if you take a secondary alcohol like this, we have learned this type of questions. Preparation we have learned. Secondary alcohol, this is because OH is at the secondary carbon atom. When this is oxidized using a strong oxidizing agent like acidified KMnO4 or acidified potassium dichromate, what happens is this hydrogen and this oxygen gets eliminated as water. So what else you have? We have CH3, you have C double bond O, and you have CH3. This is nothing but acetone. And in general, we call it as a ketone. Therefore, the answer for this question is secondary alcohol on oxidation gives ketone. The next question. A carbonyl compound reacts with hydrogen cyanide. A carbonyl compound reacts with hydrogen cyanide to form cyanohydrin. So this we'll be learning. Chemical properties we have not learned in detail, but anyways, for this I'll explain one question, one or two questions we will learn, and then we will see chemical properties in the next class. A carbonyl compound reacts with hydrogen cyanide. A carbonyl compound. All these contains carbonyl compounds. Now we'll take a simple carbonyl compound like acetaldehyde. This acetaldehyde reacts with hydrogen cyanide. Now what happens is hydrogen attacks oxygen and cyanide attacks carbon. The mechanism we will learn in the next class. So you get OH and CN. These are called as cyanohydrin. These are called as cyanohydrins. So carbon containing OH and CN group are called cyanohydrin. So this cyanohydrin on hydrolysis. Hydrolysis is reaction with water. So what happens is, now we will write two molecules of water. Now in two molecules of water, the bond between carbon and nitrogen breaks. Now water, I'll write it as H2 and O. The other water molecule, I write it as H and OH. So what happens? The byproduct is ammonia. Ammonia gets liberated. So what else we have? We have CH3, we have CH, we have OH here, and you have COOH. Now, this is a primary carbon atom. Alpha carbon, functional group. This is alpha. Carbon, alpha. So alpha carbon atom contains what? OH group. Therefore, this will be called as alpha hydroxy acid. It's called as alpha hydroxy acid. Carbon atom bonded to the functional group is called as alpha carbon. This is the carbon bonded to the functional group. And this carbon which is bonded to the functional group contains OH group. Therefore, it's called as alpha hydroxy acids. They're asking, forms alpha hydroxy acid. So the compound is acetaldehyde. The next question, the product formed when aldehyde condensation we will learn, because I'm not taught you the chemical properties. We will learn the chemical properties in the next class, and we will learn some of the questions based on this in the next class. All right, we will stop. Madam? Ma'am? Hello, ma'am? Ma'am? Fast. Nalakshmi,
Yes, sir.